We've all heard the warning, don't short a battery. But what's the real story there? Is it just a tiny little spark, or are we talking about something way more serious? Well, in this explainer, we're going to uncover the explosive truth of what happens when you short-circuit a battery. Let's dive in.
So the big question, can you actually short a battery and just walk away? The answer is, well, maybe, but the risks are absolutely huge. The real question we need to be asking is, what makes this so incredibly dangerous in the first place? And it all comes down to a really basic law of physics.
The very instant a battery gets shorted, it just unleashes this crazy torrent of energy, and that energy comes out as intense heat. I mean, we're talking about a temperature spike that is almost instantaneous and can have some pretty devastating consequences.
And, when you have that much heat all crammed into a tiny, confined space, what's the next logical step? You got it, fire. This isn't just a maybe, it's a very real and very immediate danger.
Then you have the worst-case scenario. If you get that intense heat and that fire, the battery itself can actually explode. We're talking shrapnel, hazardous chemicals flying everywhere. This is the catastrophic grand finale of a short circuit.
So what's the science behind this recipe for disaster? To really get a handle on the risks, we need to peek inside the battery and see what's happening during that short. The fallout is immediate and severe, so let's break it down.
When you short-circuit a battery, it's not just that it stops working. No, the dangers that pop up right away are way more serious. As you can see, we're looking at extreme heat, the potential for fire, explosions, and even nasty chemical leaks. This is exactly why handling batteries properly is so important.
This quote right here just nails it. Think of a battery as a tiny, compact warehouse of energy. A short circuit is like throwing all the doors open at once and letting everything rush out in one single uncontrolled burst. The result? It can be absolutely catastrophic for anything or anyone that's nearby.
But why? What makes that energy release so incredibly violent? To answer that, we got to dig into the science of the surge and look at the fundamental rule that governs all this electrical chaos.
The key to understanding all of this is a super important principle in physics, Ohm's law. It's a pretty simple equation, but it's incredibly powerful. It just says that the current is equal to the voltage divided by the resistance. And in a short circuit, it's that resistance part of the equation that becomes the star of the show.
This slide just lays it out perfectly. In a normal circuit, whatever device you're powering provides resistance, which keeps the flow of current nice and controlled. But in a short circuit, you're basically creating a superhighway for the electricity with almost zero resistance. And as Ohm's law just told us, when that resistance drops to near zero, the current just skyrockets. You get a massive, uncontrolled surge.
And that surge kicks off a devastating chain reaction. It all starts when you create that low-resistance path. Think about a coin or a key touching both ends of the battery. That causes the current to just explode, turning all that electrical energy into intense heat. The battery just can't handle it, and it fails, often in a really spectacular and dangerous way.
Okay, but words and diagrams can only do so much, right? To really, truly understand the raw power of a short circuit, we've set up a safe, controlled demonstration. Let's see what happens when we put all this science to the test. All right, for our demonstration, we've got three very common batteries lined up. We've got a standard 1.5 volt AA, a 9 volt battery like you'd find at a smoke detector, and the big one, a powerful 12 volt car battery. Let's see how they each handle being short-circuited. First up to bat, the humble AA battery. Now watch closely. The moment we short it, you see that bright spark, and the wire starts glowing red hot? It's just a crazy fast and dramatic temperature jump from such a tiny little power source. And the numbers we measured are just as dramatic. We saw a peak current surge of 25 amps. Now, to put that in perspective for you, your phone charger probably delivers about 2 amps. That means this tiny AA battery is, for a moment, putting out more than 10 times the power. It's wild. Okay, next up is the 9 volt battery. As you can see, the reaction here is even more intense. We get a bigger spark, more smoke, and a serious amount of heat. The battery itself gets dangerously hot to the touch in just a matter of seconds.
And the temperature readings? They're frankly alarming. We're seeing temperatures well over 200 degrees Celsius. That's nearly 400 degrees Fahrenheit. That is more than hot enough to give you a serious burn, and it could easily ignite anything flammable nearby.
And now for the grand finale, the 12 volt car battery. Okay, the results here are, well, they're nothing short of extreme. The instant we complete that circuit, there is a massive flash, and the jumper cable itself actually starts to melt, producing this thick cloud of smoke.
The current here is a mind-blowing 500 amps. That's enough power to literally weld metal. This demonstration makes it crystal clear. The more energy a battery stores, the more terrifyingly dangerous a short circuit becomes. The visuals are both impressive and pretty scary.
So what have we learned here? Shorting a battery creates this incredibly dangerous surge of current, all because of low resistance. Now let's get to the most important part, how you can stay safe and avoid this kind of electrical mayhem in your own life. Really, the key to battery safety is just proper handling. You should always store them in a way that the terminals can't touch each other or touch anything metal. And that old saying about never carrying a loose battery in your pocket with keys or coins, that is 100% true and absolutely critical. Also, make sure you're using the right battery for your device, give it a quick look for damage before you use it, and never try to recharge a non-rechargeable battery. These simple stuffs can make all the difference.
So there you have it, the science and the pretty stark reality of shorting a battery. It's a powerful reminder to always respect the energy that's stored in these things. We'd love to hear from you, actually. Have you ever had a close call with a short-circuited battery? Let us know your stories down in the comments. Thanks for watching.